Good evening, everyone. My name is Laura Kaminsky, and I'm the Program Administrator for the Michigan Clean Water Corps program. I'm here with Dr. Paul Steen, MiCorps Program Manager, and we are pleased to welcome you to the first ever CLMP training webinar. Before we begin, I'd just like to take a minute to review some logistics. We will be recording the webinar this evening, so to cut down on background noise, your audio input has been muted. However, since this is a training session, we want to make sure that you can ask questions. So these next couple of slides illustrate how to do that during today's webinar. First, you'll want to expand the panes in the GoToWebinar toolbar for audio and questions by clicking on the little plus signs. The audio pane will tell you if you're muted, and the questions pane will allow you to submit a question to the webinar presenters. We will have time for questions at the end of each training module today. If you prefer to ask a question verbally using your audio connection, you may click on the hand icon to raise your hand, which is the lowest icon on the left-hand side of the toolbar. At the end of the presentation, we will let you know when your line has been unmuted to ask your question. Or you may submit a question in writing at any time using the questions pane, and we will respond to them at the end of each presentation. If you experience technical problems during the webinar, please send us a message using the questions pane or call 734-971-9135 extension 117. And if at any time you get disconnected from the webinar or audio, please attempt to reconnect, and we will do the same. At this time, I'd like to hand things over to Dr. Paul Steen, MiCorps Program Manager, to get things started.
Good evening, everybody. Let's practice raising hands because I want to make sure everyone knows how to do it. Everyone find that spot where it says hands raised and click that. Let's see some hands raised. Okay, we're seeing hands. Good. Good job. Okay. Now raise your hand.
Click on the icon again.
There you go. There you go. Okay. And now I want to see, I do this at every live presentation, and since this is live, just on the computer, I still want to ask a question where you can raise your hands to this, and that is, who here has never attended a CLMP training? Put your hands up if you've never attended a CLMP training. Okay, well that gives me a good number.
Looks like about 50%.
50%. 50% haven't attended a CLMP training, or they haven't figured out how to hit the hands raised button yet. So, okay. Well, I'm going to flip to my slides a second, so bear with me. Actually, before I get to my PowerPoints for the Secchi and Phosphorus training, I wanted to just take a quick look at the MiCorps website and point out some resources to you that you will be able to use both now and later. Immediately, if you desired, you have the option of printing these PowerPoints for yourself. If you go to www.micorps.net and then under the resources drop down, which I have my mouse on, go to MiCorps Training, and this will pop up. And then scroll down a little bit, and you can see the first two bullets there are for Secchi disk and phosphorus monitoring. Those are the slides we're going to be going through, and the chlorophyll monitoring. So that's how you get this presentation, and then you can print it out for yourself. The other two more important things to show you, if you go to lake monitoring drop down, you will see the one that says CLMP documents. I'll bring that up. This page will be really important to use throughout the whole monitoring season. There are, this is where you get your procedures. This is where you get data forms. There's videos on here. I'm not going to play them right now, but for example, here's the Secchi disk, how to measure Secchi disk, and there's one for phosphorus, and then further down there's one for chlorophyll. So all really good bits of information that you can reference at any time. Also, we have this new thing called the CLMP manual, and this is a large PDF. It's probably about 70 pages or so, and this document contains a lot of background information, and all of the procedures for each one of these parameters is all contained in this manual. So it's a very good general reference to the program. Last but not least, I just wanted to show you quickly how to get into the data exchange. There's some slides in the presentations that go over this as well, but it's so nice to just be able to show you right on the website, so that's what I'm going to do. So if you go to data exchange, and then you can say either view data or enter data. So that's how you both put in your data that you will be taking this summer, as well as look at your data later and actually look at any lakes data. That's how you get to it. So I just wanted to point those out ahead of time. Okay, so with that, I'm going to flip over to the actual presentation for the Secchi disk and phosphorus. We'll start with the Secchi disk aspect of it. Well, first of all, before we even get to that, there's going to be a little background material. So we're going to talk a little bit about the program and what the goals of the program are. So this is me. My name is Paul Steen. I work with the Huron River Watershed Council. This is a DEQ program, but they have contracted with both myself and Laura at the Great Lakes Commission to manage it. So that's why you often see our names attached to this DEQ program. And there's my contact information if you wanted to call or email during normal work hours, and I can get back to you or talk to you right away. So this is actually a very old program. The CLMP was started in 1974. I believe the only program that beat us out was Minnesota. They started in 1973. So we've been doing this a long time. Back then in the 70s and throughout the 80s, this was actually called the self-help program. And over time, the self-help program developed, grew, and we added parameters, like as you can see on these bullets here. In 1998, the program was officially name changed to Cooperative Lakes Monitoring Program because we felt it was a little more descriptive and told you right there in the name what we do. So this has been a program that's grown over the years, grown in people and grown in lakes and roll too. There's two main goals to the CLMP. The first one is an education goal. Just because you're listening to this webinar really puts you above a lot of people in terms of interest in lake management and lake monitoring. And it is our goal in the CLMP to reach people like you, reach people like the ones who came to our live training last week. And we're hopeful that through our education of you, you can then go on to talk to your neighbors, other people that live on your lakes, and through this network, build up a group of educated citizens that understand lake management and how to take care of lakes. And to do this, we have developed a few things to aid you in your education of your neighbors. There's fact sheets available. That actually is at that page I just showed you, CLMP documents. There's fact sheets. You can print those out and you can pass those around so people know what you're doing. There's also presentations available. If you were planning on giving a presentation to your lake association, you can use this presentation linked here as the base, and then you can add in, there's places for you to add in your own data and pictures and that kind of thing. So that would be an excellent place to start if you're thinking of giving your own presentation. The second goal of the CLMP is to generate data, obviously. That's why we're out there monitoring. It's both data for you to get your baseline information, to understanding what's happening in terms of the trends on your lake. But at the same time, we're also collecting data to be used at a statewide level. So the DEQ is also interested in this data. They don't have the manpower to do it all themselves, which is why we really rely on the residents at the lakes to get a lot of this monitoring done. Now, this is probably more applicable to a live training, but I just like to point out that the CLMP really is about the baseline lake monitoring. We are interested in management, but it's not something that this program covers generally. It takes resources that go beyond what we have. So at this training, we're talking about the specifics of monitoring, and management discussions are for another day. This is kind of what I showed you already. We have these Secchi phosphorus and chlorophyll videos that we want you to watch, and there's that website. Some other new features, I mentioned the CLMP manual. Also, I didn't mention it yet, we have quick reference procedures. These are shortened versions of the procedures. The idea is that they're 1 or 2 pages, and you can print them out and bring them on the boat with you to use as a quick checklist. So they're a little more readable than the full procedures which are found in the CLMP manual. However, the CLMP manual does contain a lot of detail that we want to keep fresh on people's minds. So I recommend to read those full procedures at least once a year before the season starts. Right about now would be a good time to get that CLMP manual and read through the full procedures. Okay, so what are we talking about in the CLMP when it comes to monitoring? All these parameters listed here are what are considered to be trophic state indicators. Trophic is from as many words, it's from the Greek, and refers to nourishment. So taken in the context of lakes, that nourishment is referring to the amount of productivity or algae growth in a lake. So all of these parameters are getting at the underlying food web in a lake. Is there a lot of food in a lake? Is there not very much food in a lake? And what we're finding here then will have real implications on the management of that lake. First off is transparency. This is just a little outline of what we're going to talk about with transparency. We're going to talk about how to make those measurements. We're going to talk about the schedule for making them. And one thing that I'm going to stress probably numerous times, and I'll apologize ahead of time for just repeating myself, will be that we want at least 8 measurements over the course of a summer to when we take transparency. And then we'll take a look at the seasonal variability to transparency, which gives some explanation for why I want 8 measurements. So this is an example of a Secchi disc. It's one of the oldest pieces of water quality equipment that we know of. It was developed by an Italian scientist, Angelo Secchi, back in the 14th or 15th century, somewhere in there. Back then it was a disc that was fully just painted white. Over time we've added these black quadrants to it to make it easier to see. So we do Secchi because it is cheap and easy, quick to go out there and get a measurement, and it can still give you good information. Its function is very simple. In clear lakes, you can drop that Secchi disc a lot further down into the water column and still be able to see it. In lakes that are turbid, the light doesn't penetrate as far, and you can only see a little bit down into the lake using a Secchi disc. So it gives a very quick and easy measurement of how clear that water is. Now, it's not the best measurement in the world. We're specifically in this program interested in the amount of algae that is growing in the lake. But there's lots of other things that can make a lake more turbid. And I'm sure with all of you spending time out on lakes, you can think of some of them. Boats churning up the water would be a big one. That it doesn't necessarily affect the trophic status of your lake, but can make things more turbid and hard to see. So suspended sediments, marl makes lakes more turbid. Even the color of a lake can make a lake or make a Secchi disk harder to see. So there's these lakes called tea lakes, which are full of dissolved carbons, kind of like when you drink tea. And that brownish color actually makes the Secchi disk harder to see. So if you have a kind of lake that's really affected by suspended solids or marl or color, Secchi disk measurements won't be as accurate for you when it comes to trying to get a sense of the amount of algae. But for a lot of lakes, it works pretty good, and it's easy and quick, so that's why we continue to do it. So I'll walk you through how to take a Secchi disk measurement, and it's really easy. There's not much to it. You lower that disk down until you can no longer see it. You then raise the disk up until you can see it again. Those will actually be two different depths because of how your eyes are able to track the disk when it goes down. So you lower it until it disappears. And actually you want to take a note of what that depth is. You raise it until it reappears, and you take a note of what that depth is. And then you want to average those two depths. And that is the official measurement that ends up going on the data sheet. Now there's a few things to remember to make sure that the data you're collecting is accurate. First of all, don't be like my friend here, and don't use sunglasses. So anything that affects your visibility and how far you can look down into the water should not be used. So remember to take off sunglasses, don't use a view scope or anything like that. If you have a choice in the matter, always pick the shadow of the boat to do the Secchi disk measurement in. If you are doing the Secchi disk measurement at high noon on a cloudless day, it's possible there may not be a shadow, but whenever you can, you want to pick the shadow. And that's just so that we're consistent from lake to lake and from over time. So we always try to do it the same way. And third, we are consistent in your timing. So if you decide that the best time for you to go out is 11 a.m., then try to every week go out at the same time so that lighting conditions are consistent. In general, you want to go between 10 a.m. and 4 p.m. So during the brighter parts of the day, don't go out there really early when the sun's just rising or when the sun's starting to set, because obviously that will affect how well you can see into the water also. So you're trying to be consistent with that. You can also try to be consistent with the weather. If there's a really bad, stormy day, don't go out that day. Even if you were planning to, just wait another day or two for the good weather to come back and go out that day. So you try to be consistent with the timing and with the weather within reason. Obviously, if it rains for 2 weeks straight, you still need to go out there and get that measurement. But if you can wait a day or two, that's fine to wait. So as I mentioned before, and I'll mention again, with Secchi disk measurements, the goal is to get at least 8 measurements over the course of the summer. If you do it every other week, you'll end up with about 8. If you do it every week, you'll end up with 18, 19, something like that. So obviously the more data the better, but the absolute minimum you need is 8. If you don't get 8 measurements, it means we can't calculate an average and put a dot on the trend graph for the year. The reason we insist upon at least 8 measurements is because your lake changes over time. So throughout the summer, there'll be different algae growing and dominating. In the early spring, there's a lot more diatoms, which is a particular kind of algae that needs silica. And as all the silica is used up, the diatoms start dying off and the green algae do well. And then as the temperature gets higher in your lake, the blue-green algae will start doing better. So you'll have this natural shift in algae populations on your lake. And as a result, things are just different. So when you do your Secchi disk measurements, you want to capture that whole variety. So that's why we do it from May to September, and we try to do it every week, every other week at a minimum. This is what your data form will look like. This is a 2014 version, but the 2015 will be exactly the same with maybe a little changes in the dates. So this is what you're taking out with you on your boat to fill out. The top section up here, lake name, county, township, pretty straightforward. Lake sampling site number or field ID number. This is the number that is assigned to you upon registering with the CLMP. So that number is one that if you have talked to Jean Roth in your registration process, she'll say, oh, well, we'll make sure we get that to you. And then she sends a little card with that number to whoever did the registering for your lake. Each one of those sample site field ID numbers should have a latitude and longitude associated with it. And that's something that, once again, you get in a conversation with us. So if you registered your lake this year, you should have gotten this sampling site field ID number. You also should have gotten a latitude and longitude. If you have not gotten a latitude or a longitude with us, then go ahead and email me, and we'll get that straightened out and make sure that you have that latitude and longitude. That's an important number because that dictates where you're going to do all of your sampling. So we're consistent in our sampling. We always try to go to the deepest part of the lake, and so whatever the deepest part of the lake is, that's what we assign that latitude and longitude to. So if you haven't gotten that, make sure you contact me sometime this week, and we'll make sure that we can pick that out. A lot of times we actually rely on your expertise to figure out where the deepest place on the lake is, because not every lake has a good bathymetric map. So we may just turn around and ask you, and then we'll record that as the official latitude and longitude. This is the way the data form works in terms of dates. You'll have a set of dates here, like May 11 through 17. That means you take one measurement in that range, and these go weekly. So you fill out the date sampled, the time of day, Secchi depth, that's the average. It's not the other numbers, but just the average. And we always round that to the nearest half foot. Any weather conditions or unusual conditions, and so forth. And then throughout the summer, you just hold on to this one data sheet. And as each week goes by, you just fill out another line, making sure that, once again, you stay consistent in the time throughout as best as you can. I just went over this, so I'll skip this slide. On the back of the data form, this is what we see. We ask you to draw an outline of your lake and then mark that location, general location at which you sampled. And this is useful if we ever have an issue come up where we're not really sure that people sampled in the right place. This is just something else to refer to make sure that the data quality stays good. On the bottom, we see you check one box. You check if the data have been entered into the MiCorps data exchange. or the data have not been entered into the MiCorps data exchange. So we love it when people can check this first box and enter the data themselves. And I'll talk a little bit about how to do that. But if you're not comfortable with a computer or don't have easy access, you're not required to enter the data into the MiCorps data exchange. In that case, we will enter it ourselves. Then no matter what you do, we ask that you make a copy of this data sheet for yourself, and then you would mail it normal snail mail, U.S. Postal Service, to MLSA at this address. So that's how we keep a long-term record of the data. We'll also have, the data on the data exchange, but we want the paper copies too. So what does the data exchange look like? The data exchange is an online database. You can enter your data, you can search your data, you can find data from any lake who's been in the program going all the way back to 1974. We love it when people use the data entry. Those who do enter their data in this system are then eligible for going into a random drawing, which happens the next year to see, someone will be randomly selected to get a free parameter registration. So that's the reward for entering into the data exchange. Now this is really important, so write this down while you got your pen handy. To get a login and a password to get into the data exchange, you need this in order to enter your own data. You can either email or call Catherine Hollins, who works at GLC, and she will be able to set you up with a username and a password. So make sure you get, I'll just wait 10 seconds for everyone to make sure that they get that number. Okay. Oh, I showed you this on the actual live website, so that's how you get to the data exchange.
Actually, there was just a question to review that for anyone who came in late. So good timing. Okay,
yeah, good timing. Okay, well, I won't go back to the actual website, but because this just shows how to do it pretty easily. So that it's just a simple drop-down menu. Once you're in there and you say enter, if you want to enter your data, this is what pops up. It will ask you for your username and your password. And in case you didn't get that email address and phone number, it's here once again, right on the web page. So you enter that. Once you do that, it will send you to a page that shows you the site ID number for which you can enter data. So it's pretty easy. You just click on that site ID number, and then it will ask which parameter you want to enter data for. And in this case, you would hit Secchi disk. And it brings you to this type of system. It's a very easy system to use. It's really, I always like to say, it's no harder than buying something on Amazon. So if you've ever done any online shopping, you would do fine entering your own data, because everything is just a drop-down menu. So you have your data sheet in front of you, and then just using the drop-down menu, you're able to enter that data really one row at a time from your database. You'll get to the bottom of this page, and you'll say enter, and then you can say enter more Secchi data, and then you'll be able to put in the next row from your data sheet. Now you have the option to either enter your data every week consistently, or you can just wait to the end of the season and enter it all at the same time. That's totally up to you. And then after a good number of months, because we need to do a lot of lab work with the other parameters, we'll produce a data report that goes through your results. And starting new in 2014, we developed these for each individual lake, so each lake will get their own data report. It will include something like this. Well, it will include graphs for all the parameters you're enrolled in. This is an example of a Secchi disk graph. It doesn't show every single measurement you took. Each dot is an average for the whole year. Now, this lake did a good job between about 1976 all the way through about 2005. Then I don't know exactly what happened here in these years. They either didn't register with the program, so we don't have data, or if they didn't get at least 8 measurements for any of these years, that could be another reason why we don't have a dot showing up on the graph. So this is another example of why you want to make sure you get at least 8 measurements so that the data is always can be recorded in these long-term trends. Now this graph I think is very cool and shows the usefulness of putting everything into a long-term database. So we had a group in 1980 monitor Perch Lake in Secchi. They did it for about 4 years, and then there was a long break. Now I don't know the exact specifics, but I would imagine what happened is that a new volunteer found the program and registered Perch Lake again. Probably didn't even know that they had previous data on Perch Lake from the 80s. But because they went through this program and all this data was recorded in a long-term database, they suddenly have all this historical data. And sure enough, by looking at that historical data, they can see their lake has lost a lot of transparency over time. So that's very useful information from a management point of view. So in being a monitor with our program, you're helping yourself right now, but we're also helping future generations in building data into this database so that they will be able to use it. Okay, so that's really it for Secchi. We can do a few minutes of questions, I think.
Well, you already showed the data entry portion of the website, but maybe you could just show them how to access the documents, the CLMP documents page, and the training presentations again.
Okay,
for anyone who came in
missed
late.
it.
Yeah.
All right, let me get out of PowerPoint. I'll go to the website.
And
yep, go ahead.
While Paul's doing that, feel free to type in additional questions if you have them, or click on that hand icon to raise your hand, and we can unmute your line if you want to ask a question verbally.
Okay, this is the website, www.micorps.net. The two things I'll highlight to you, if you go to resources and then MiCorps training, this is the PowerPoints for all the parameters that we do. And then if you go to lake monitoring, this is also where you just even enroll in the program. But in terms of this presentation, CLMP documents, this brings you to everything you might want to print out, and that will assist you in monitoring. So data forms, procedures, schedules, all that stuff is at this website.
Okay.
Anything else?
Yep, we just got another question. Do you only have to take a Secchi measurement at the deepest point in the lake, or should you take measurements in multiple locations?
Right. So for this program, the only data that we are interested in is from the deepest point on the lake. Now, if you want to, just for your own curiosity, want to do the Secchi disk in other locations, that's totally up to you. But we will only be taking data from that deepest point.
Okay. Any other questions before we move on to the next module? Oh, we just got another one. So where are the lake monitoring reports on the website, the ones that show the historical measurements? Thanks for that question.
Okay, I can show you a couple things here. If you go to lake monitoring data reports, you can, there's a couple things here. Back historically, we have always done one big annual summary report. So those are all listed for past years. In 2014, we just started with individual lakes, so you can click on that. And then this is a list of all the lakes that were enrolled in 2014. And as every year goes by, we'll add more and more lakes to this list if they enroll. So you can find all the data from these. The other way, go to Data Exchange and say View Data. And it will actually bring you to a little survey, which we love it if you fill out. I'm just going to say skip for now. And then we're going to say I want to look at lake data. And then here's your lake. You can pick your county, your watershed. You can find every lake in this list, state ranges, and then all the parameters you want. And then you can either have that shoot out an Excel spreadsheet to you or just normal HTML, just a normal web page. So if you're interested in any particular lake, the historical data, and it's not on the other web page I showed you, then you want to search in this list to try to find it. So I should probably keep going to the...
Actually, one more question.
Okay.
Or actually, it's a comment. Okay, it looks like she resolved that. There's one of our volunteers says she needs to get the longitude and latitude of her lake, and she will email you to get this.
Definitely, yes, please do. Okay, we're going to go to phosphorus. Phosphorus is pretty easy, and I'm guessing a lot of you probably have already done phosphorus measurements already because we have the spring phosphorus parameter, and for a lot of lakes, the ice has come out. So let's take a look at that. When you register in phosphorus, there are two things you can do. You can register for spring phosphorus, and you can register for a summer phosphorus. You can do both or just one. There's two separate mailings for each of those. So everyone will have gotten their spring phosphorus information, and this is everything that would have been included. And then sometime in early August, you will be getting this set of materials again in the mail for the summer phosphorus. So that's kind of how it works. So don't expect to have everything right now. That's just a quick shot of the tools of the trade. But it's more important to talk about this stuff here. Spring phosphorus, we ask that that measurement is taken within 14 days after the ice melts off of your lake. Every tiny little ice chunk doesn't have to melt off the lake. If there's little bays that are still frozen in, that's fine. The idea is just we want to be able to get out there shortly after ice out, shortly after the water has turned over, because what we're going after is a phosphorus measurement that represents the whole lake. So that turnover that happens in most lakes churns up the water, and it brings phosphorus from the bottom to the top and makes it so that no matter where you sample, things should be relatively the same. Just here's the schedule for spring phosphorus. The schedule is flexible because it's just within 2 weeks of that ice out, and we ask you to determine when that ice out is. The turn-in is not flexible. The turn-in date for spring phosphorus, which is coming up in about a month, is on June 2, and it's before noon. So you look at the schedule and you find your county on there, and you bring your sample, which needs to be frozen. You bring it to that address by noon on June 2. There's a little bit of flexibility. If you absolutely cannot make it on that particular date, you have to reach out directly with the staff at that location in which you're assigned and see if you can turn it in early. A lot of times they're okay with that, but they really need to know ahead of time if you're coming. Because if you come to their office and just drop it off at their front door or drop it off when the person who's familiar with our program isn't there, then your sample could potentially get lost or ruined, and that would be a big waste of time for you. So If you can't do it by noon on June 2, then just make other arrangements beforehand. In late August or through mid-September, depending on where you're located in the state, you'll take another phosphorus sample. This phosphorus sample is just a surface grab, just like the spring. In this sample, though, you are interested in the top layer of water. So a lot of lakes stratify and create these layers. And in the summer, especially late summer, usually that stratification is very distinct. So when you take a surface grab off of a stratified lake, you're really just looking at the very, very top of the water. And that's the water that is where a lot of the algae production is going on. So when we take this summer sample, we're going after the phosphorus available to the plants and algae in the growing season. There'll be a second schedule for summer phosphorus. And this one is a little more particular. Depending where you are in the state, you'll have a different sampling date and a different turn-in. Once again, you have to turn the sample in frozen. It has to be before noon, and then on the date given, which varies. And once again, you have to make other arrangements with that location if that particular date doesn't work for you. Okay, so we're going to head out to the lake. Let's pretend we're in our boats. We're going to that deepest spot, which you'll have the latitude and longitude for. That's your primary sample location, same spot you do Secchi. And you get out there and you can start filling out your labels for your phosphorus bottles. So you always want to make sure you use a sharpee or a pencil, never a pen or a marker that can run in water. So it has to be something that can get wet and you'll still be able to read the label. Pretty much just go through this and fill it out as shown here. The tricky things, I guess, are under analysis or parameter code, you enter GA. And under chemicals added, you don't put anything. And that's the top label. The bottom label is exactly the same, except under location, you're going to put REP. That stands for replicate, along with your lake name, because you're actually going to be taking 2 phosphorus samples. And you'll put the top label on one bottle and the bottom label on a second bottle. So once you're out there, take the cap off, being very careful not to touch the inside of the cap with your fingers. Don't touch the inside of the bottle with your fingers. Keep your fingers away from it at all points. And you want to rinse that bottle twice. And then you hold the bottle in your hand in such a way, it's really easy to show you this in person, so I'll just have to kind of explain it on a webinar, but you hold your bottle in such a way that the opening is facing down right into the water. And you push that bottle into the water so that no air is getting out, and that because no air is getting out, that also means no water is getting in. Because you don't want water at the very, very top. You want to go down about to your elbow, maybe a little further than your elbow. And once the bottle is at that depth, that's when you can twist your arm and let the water out, or sorry, let the air out, and the water will come into the bottle. So you want to get down about 1.5 feet before you actually get the water. So that's just the little technique that you use to make sure that happens. Pour a little bit of that water out about to that point, because you are going to bring this back to your house and freeze it right away. And so if you don't pour some out, the water will expand and potentially pop your cap off or crack the bottle, and then your sample will be ruined. So make sure you give a little headspace for freezing. You will put so you do this twice, so notice the 2 bottles there. You put it in a cooler with an ice pack and bring it back to your home and get it in the freezer. So you have to freeze these things, or they will get rejected by the lab, and they have to stay frozen. So even when you go to drop them off, you'll need to bring them in a cooler to make sure that they stay frozen. Fill out your data sheets. What's written here is very nice. Please remember to do it. put the data sheet in its own baggie, and then that baggie goes into the bigger baggie with the samples. And the reason we ask that is because these data sheets can get really wet. And if you just stick the data sheets right in with the bottles will sweat a little bit, and the data sheets will just become like, well, you know what wet paper is like, so it's kind of gross and hard to use. So each data sheet into its own baggie. This is what your data sheet will look like. It has a lot of the same things that we already talked about with the Secchi. You record the date that you did it. You record the date of ice out. Actually, in this particular example, just from coincidence, this person actually didn't even get it within 2 weeks of ice out as we asked. So a day or so away from ice out isn't a big deal, but if you start getting 4, 5, 6, 7 days outside of the date of ice out, we will have to reject your sample. So get as close as you can to the ice out date. There's a spot to put the time and wind conditions, etc., and when you turn it in. And then your back of the data sheet looks very similar to the Secchi. It has, once again, a place for you to enter if you've entered this information into the data exchange or if you haven't. And then this data sheet, you don't need to put in the mail because you will turn it in with your frozen sample. So one question that people ask is, well, I don't know what my phosphorus measurement is because all I did was take a water sample. So what data could I have to enter? And then the answer to that is this information on the front side of your data sheet. If you go into the data exchange, there will be a place for you to enter this information. And then when we have your sample back from the lab, we'll match your information with the sample, and it will all go into the data exchange together. Reminder of freezing it until you turn it in. And then you turn it in according to that schedule that we went through. Oh, we talked about this data component for phosphorus. I can't remember why I'm showing this again. I'll keep going. Here's an example of the type of data produced. You would have, I always divide spring and summer phosphorus separate from each other on the graph. So this would be an example of spring phosphorus. On this particular lake, Quarry Lake, we actually see the phosphorus levels going down over time, even though there is a lot of noise in the data too. But the overall trend is that the phosphorus is going down. And evaluation forms. Well, this is meant for the live audience, but it's a good spot to just remind myself that we are going to actually have an evaluation for this webinar. And that is going to be coming to you over email in the next couple of days. So just like as if you were an audience at Boyne Mountain, we really do appreciate what you can give in terms of feedback for how this presentation went. If you feel like it met your needs, if you feel comfortable in the monitoring, we want to know that stuff. So please take the time to fill out that evaluation when it comes to your email. Okay, so we have about, let's say, 6 or 7 minutes for questions on phosphorus before we take maybe a couple-minute break.
Okay. We did get one question during your presentation. It's kind of a general question. Will this webinar be archived on the web with the audio? And I can answer that. This being our first time trying this format, we are recording it, as I mentioned at the start. And assuming that recording turned out all right and there weren't any problems with it, we are planning to post this on the website. And we can let all of you participants know when that is available. So stay tuned for more. Are there any other questions? Phosphorus?
Or Secchi.
Or Secchi. Feel free to raise your hand, too, if you want to just ask your question verbally rather than typing it in. You must be doing such a great job. Paul, there are any questions?
That's fine. It's fine. We can all take 5.
Well, think about it. We can answer questions later on, too, if you think of any. And I guess we'll take a short 10-minute break and then meet back at 7 to start up on the next chlorophyll training.
Great.
We're going to put our phone on mute for the time being, so we'll be back in 10 minutes. Hi everyone, welcome back. While we were taking a short break, we got a couple of additional questions in, so we will go ahead and address those now. For Secchi, you won't be sampling during rain, etc., but what about following a heavy storm? I.e., if the water is full of sediment from a storm, should you wait until it clears before taking your measurement?
And the answer to that is that's a good idea. Wait a couple of days after big storm or rain events. It'll just get you more accurate data. So within reason, once again, you don't want to miss weeks at a time because you're waiting for the perfect day. But if it's just an isolated storm and you can get out there a couple days after, that's good.
Okay. And the other question was, is it possible to enter data from previous years that were not entered so we can get long-term graphs?
Yes. So the answer to that is yes. Though when you do that, it's typically a good idea to email me and let me know that the data is there in the database so I can go and look at it. Data doesn't automatically pop in as soon as you enter it. It needs to be checked, just a quick data quality check. And if you enter it at a time when I'm not expecting it to show up, I may not see it. So yeah, so just tell me that you're going to do it when you do it.
And Wellington, I see that you have your hand raised. Could you just send us a quick note in the questions box if you still have a question you wanted to ask verbally? Otherwise, we'll just move on, assuming that that was your question you had. In the meantime, there's another question here. I missed my 14-day window for phosphorus, so should I continue with a summer test or not?
Yes, definitely. Well, I guess it depends. If you're only a couple of days outside of that 14 window, still do the spring phosphorus. If it's been over a week, then you've missed it. In terms of summer phosphorus, there are two different things. So still plan on doing the summer phosphorus no matter what. Because spring and summer are separate from each other.
No, he's a couple weeks beyond.
You're a couple weeks off. Yeah, then at this point, don't worry about the spring phosphorus, but yes, do the summer phosphorus.
I think that's it. And Wellington, if you still wanted to ask a question, send us a quick note. Otherwise, we're going to move on here, I guess.
Okay.
Oh, yes, the hand went back up. Okay, all right. Let's see if I can figure out how to do this. All right, Wellington, your line should be unmuted. You can go ahead and ask your question.
You answered it already. Thank you.
Okay.
Okay,
all
great.
right, thanks.
Welcome to the recording. It's good to get another voice out here. Okay, well, we're going to jump into chlorophyll. Chlorophyll is definitely a more complicated parameter, which is why we have always required training for it in order to do it. If anyone has recently joined us, my name is Paul Steen. I'm the MiCorps and CLMP program manager, and here's my contact information to ask more questions at a later point. So we're moving on to the third parameter on this trophic state indicators list, chlorophyll A. Chlorophyll A is probably the most direct measurement of the amount of food in your lake, because this is really the algae. That's the base of the food chain. So here's a little bit of an outline of what we're going to talk about. What is chlorophyll? The schedule, how to collect the water, and then how to do filtering. So in chlorophyll, there's two phases to the monitoring. You both collect the water and you have to filter the water. And then some more information on trophic state, what it means to be a trophic state indicator, and information on variability and trends. So first of all, what is chlorophyll A? Well, if you can recall back to high school biology, chlorophyll A is a molecule. It is an organic molecule, which means it's composed of carbon and hydrogens and oxygens. It is found in chloroplasts, and what this molecule is, it captures light, essentially. It captures light, turns it in, using energy, turns it into carbon. So it's the piece of the productivity chain that is producing organic substances, basically. So this ranges, they can range from individual cells containing chlorophyll. It can go up to colonies, and then excessive algae becomes more and more obvious as phosphorus and other nutrient levels go up in your lake. I should also point out, let me back up a second. The reason we do chlorophyll A specifically is that chlorophyll A is the most prominent type of chlorophyll that's found in the lakes in our area. There's also chlorophyll B's and C's, which have slightly different structures. But chlorophyll A, since it's the most common, that's what we are measuring for. Sampling schedule. This will look very familiar. It's set up the same way the phosphorus schedules are. Depending on your county, it will be different with different turn-in dates. There is 5 different times that you are measuring chlorophyll. So over the course of the summer, you'll do it 5 times. You'll essentially do it once a month from May to September. Now that final measurement is always a little odd, and that very much depends on where you're located in the state. You can see how it changes from section to section on here. For the most part, you're always between the 10th and the 20th of a particular month. So May, June, July, and August are always going to be between the 10th and the 20th. So you just do it someday within that date range. And then that final 5th event is one that's different. Now there are also 2 turn-in dates for chlorophyll. The first turn-in date you have is the same no matter where you are in the state. It's July 21. It will be before noon on that date. And in this, you are turning in what you did for event 1, 2, and 3. And then your second turn-in date, which corresponds with the same day that you also turn in your summer phosphorus sample, that will have 2 events associated with it. So it's the chlorophyll that you took in the August and then in the September sample. Now we had to make a change this year for people who are in the UP in those circled counties there on the bottom. We did have to make a change because of just logistic issues with the turn-in location. They were unable to be in the office for samples 1, 2, and 3. So for those counties only, you actually only have a single turn-in date instead of 2. So I just wanted to point that out clearly so that you don't go there and expect to find someone there, because you won't. So that's what's going on in this slide. Just like we saw with Secchi, things change over the course of the season, and that's why we're looking at every month doing a measurement. And now when I was talking about Secchi, I stressed how you needed 8 measurements. Now we have the same issue going on with chlorophyll. To get a good measurement, we want you to have done 4 or 5 of those months. So if you only get out to, let's say you only do it twice, you do it in May and then you do it in August, well, that's not going to be good enough. We'll produce the results from that data, but those missing measurements will mean that we will not be able to calculate that overall data point to put in the trend graph. So you really do need the 4 or the 5 months being monitored in order to produce good data that will be used in that overall trend graph. So make every effort to do that. You should have, I think coming this week actually. I don't think you would have gotten it yet. I think coming this week, Jean Roth from MLSA is going to start sending out chlorophyll sampling packets. She holds off till now because a lot of people pick them up at the live in-person training. If you requested printed out data forms, you'll be getting these things listed here. If you are a first-time registrant and you asked for it all to be mailed, you will be getting all of this equipment. At an in-person training, we dump out all this equipment onto a table and kind of go through it and make sure that you have everything in your packets. But since you guys don't have your packets yet, we won't do that. But it's something that you can do when it arrives at your house. Bring up this presentation again and go through the slide and make sure you have everything that's on here. If you discover you are missing a component, then you communicate back with Jean Roth, who is the one who got you registered and everything. Probably most people have already dealt with her if they have recently registered. So you should have her email and contact information. For people who have done this in the past, you don't you buy what's called a resupply kit. So you don't have to get their sampler again and everything, but there's a set of consumables that you use up every year. So people who've been in the program 2 or more years just get a few things that will come in the mail. There's also things that you will need to supply in this, both safety equipment, so your PFDs, sorry. You'll need an anchor, you'll need sharpee. I think the important thing on this list is you need a measured line. So we don't provide a line that you will attach to your sampler, but you will need to provide your own line. And you can use the same freezer pack that you use for your phosphorus samples. Okay, step 1. We are going to head out to that deepest point on the lake, the same place you do phosphorus, same place you do Secchi. And this is where we're going to get a water sample, which we will then filter at a later point in step 2. So step 1, getting that sample. This is what your sampler is going to look like that you'll bring out with you. This whole thing is disassemblable. You can take it apart. You can take that bottle cap off and then pull off the rubber stopper. And after you do that, that retaining chain can be pulled off over the top, and you can pull out the big amber bottle. Underneath the amber bottle are 2 dumbbell weights. Now those are not glued in or sealed in. They're in there freely. So they're very easy to drop over the side of the boat. And people always tend to do that. So I'd say every year someone drops their weights over the side of the boat. But the reason we don't glue them in is because they need to be taken out every time to dry. Otherwise, the whole contraption will rust out. So that's why we do that. So you're headed out in the boat. Double check your equipment list. Make sure that you have everything. When you get out to that deepest point, you can start filling out your data sheets, which I think we'll take a look at right here. It's the same basic data sheet you've seen. It's got the site ID number, latitude, longitude, and then this is data form 1. So this covers the first 3 events. So it covers May, June, and July. So when you go out in May in a couple of weeks to do this, you'll only be really filling out this part here. And then in successive months, you'll be filling out the other 2 parts. it says Secchi depth on here. You do need to, in order to do this properly, you need to do a Secchi disk measurement too, and I'll tell you why in a second. So there's a spot for the Secchi depth. There's also a spot for the composite sample depth. In this example, it's 38. You notice that's twice the Secchi depth. So you take the Secchi depth and you double it, and that's what you call your composite sample depth. And I'll show you what that means in another graph. On the back of the data sheet, you once again have the outline of the lake. You have the check boxes for if you entered this or didn't enter it. And then just like phosphorus, what you do with your data sheet is that you put it in its own baggie, and then you turn in that that frozen sample to the spot indicated on the schedule. So that's how you turn the data sheets in. They go right in with your samples. Data sheet 2 is very similar. This data sheet covers August and September. So the fourth and fifth sampling event. Okay, so we're out on the lake. First step, do that Secchi disk measurement. We just talked about it, so I won't go over it again, but that's key to this. So do the Secchi disk. And this little cartoon shows why we are taking a Secchi disk depth. Here, let's say we're going down about 10 feet. That's as far down as we can see with this Secchi disk. Well, but light actually has the capability of penetrating to pretty close to twice the Secchi depth. It's very, very close. So it's kind of interesting. So you can only see down 10 feet, but light is able to penetrate further than your eyes can see. So that goes to about twice the Secchi depth. So when you drop your sampler in, you do it at twice the Secchi depth because you're trying to collect water that has, and anywhere there's light hitting it, you want to collect that water because anywhere there's light, there's going to be algae, and that's what you're going after to get the chlorophyll. So that's the reasoning for that. Okay, so disassemble your sampler. This is the point where people knock things off and lose their weights, so be careful. You disassemble your sampler because you're rinsing that jar a couple of times with lake water. After you do that, you're actually putting the sampler back together. Then you want to check out your measured line and pull out enough line so that the sampler can drop to twice the Secchi depth. Now, a really nice trick to do this quickly and accurately and so the line doesn't get tangled is that you get all that line, just throw it all into the water so that it doesn't wrap around your foot or anything like that when you eventually let go of this sampler. You can then use a clothespin and clip right at twice the Secchi depth on your line so that when that clothespin hits the water surface and the line's taut, you know that you're at the right depth. So that's a nice little trick for making sure you can be accurate. When you're lowering it, you want to just let it free fall. So you actually just release the rope and it drops. That's what the weights are in there for, is to make sure it drops quick. Once it does hit the proper depth, you immediately start bringing it back to the surface. You do this relatively slow, but the important thing is that you're doing it at a consistent rate. This may take some practice because you want to do it at a consistent rate, but you also have to do it at just the right speed. And what that exact right speed is, I can't tell you because it really just depends on your lake and how far this thing drops. The reason for this is because when you pull it out, you want this bottle to be 2/3 to 3/4 full. If you pull it out and this bottle is completely full, that means you didn't pull it fast enough. Because you want to collect water over the whole lit zone, if it's full, you don't know if you pulled it, if the bottle filled up at the very bottom or if the bottle filled up at the very top. So you can't be sure where that water has come from. If the bottle is too empty, it means you pulled it up too fast and there wasn't enough time for the water to get into the bottle. And if you don't have enough water, then you're not going to have enough to do the next steps. So that's why we say get it 2/3 to 3/4 full. And if you're not in that range, then dump the water out and try it again. And as you do this again and again, you'll get better at it. But I can almost guarantee you that it will take you a couple tries to get the hang of it. So just get ready to disassemble the sampler, dump the water out, do the whole process again. Once you have filled up that big bottle, give it a couple of, invert it a couple times, swirl it a little bit to get all the algae cells in there moving. And then you're going to have 2 smaller rectangular amber bottles that you are filling up to the top. So in this picture, the person's right hand is holding the big bottle, and the little hand is holding that smaller rectangular bottle. So there's examples of those. Once you do that, you want to put in 5 drops of your magnesium carbonate. This is a preservative, and it's used to prevent the chlorophyll from starting to break apart while it's in your water. So when you do this, first off, I should mention, give that little magnesium carbonate bottle really vigorous shakes. Really make sure it's all mixed up in there, and then you do your 5 drops in each one of these bottles. And then once you got your water, then you are packing it up with your ice, and you're headed back to shore. So that kind of concludes the whole water collection phase in the chlorophyll sampling. But it gets better, because now you get to do something you have to be pretty specific and careful on. So you got your water sample. You're actually going to head back to the house, get into an area that does not have light shining right on you. So typically a kitchen is just fine, and you want a sink also. So get into your kitchen and close the shades so the light isn't shining right on top of your samples. And then you'll get out this series of equipment to do the chlorophyll filtering. You'll have a plastic syringe, flexible plastic tube, a filter holder, filter discs, tweezers, and also a safety pin. Those are used together to fold the filters. And then when you're all done filtering the water, the filters are going to go into these little storage vials, and you will label them. There's a few things that you need to provide. Once again, you're recording everything with a Sharpie or a pencil on the labels. You will need aluminum foil, so that's something that you'll have to provide. And then I believe actually we provide the Ziploc freezer bag, so you don't have to provide an extra one of those. And then I believe we also provide a pin. I should change those on this list. But then the coffee filter, paper towel, the only purpose that really serves is to keep your counter from getting soaked. So that's up to you on how you handle that. Okay, so the filtering process is pretty tricky, and it's pretty specific. This is the reason that we've always had in-person training for this parameter, because we'd like to kind of practice it and show it right in person. So it's kind of hard to demonstrate on a PowerPoint. We have made a video of this. We're not going to actually watch it now because the technology does not have the capability of streaming a video. So what I'm going to do is give you an assignment. So we're going to kind of walk through this whole process with still photos. But as soon as our time here is done, at 8 o'clock, your job is to go to this website, the CLMP Documents HTML HTML website, which for those of you who were here at the beginning, I showed you how to get to that. And then go to the chlorophyll video, and your job is to watch that chlorophyll video right away. Now, you don't have to go through the whole video. Fast forward till you get to 5 minutes and 50 seconds, and that's about where the filtering process starts. And then you can see me doing it in real time. So until you do that, I'm just going to give you a sense of, with some still images, what's happening in this process. So you want to lay out all of your equipment on the counter. You'll fill out some labels. This is the way they look. Once again, you'll have two because you'll have a replicate and you'll have a normal. CA goes in an analysis or parameter code. And then MgCO3 goes in chemicals added. That's, remember, we added that magnesium carbonate when we were out on the lake. On your second label, it's the same thing, but make sure you put REP by the lake name. Okay, so the first thing you do, this white circular thing here, this is called the filter holder, and you can actually unscrew it. This thing unscrews, and then there is the back end of this is this, and there's like a little metal screen. That, using tweezers, you're going to take one of your pieces of filter paper and put it on that screen. And this is all in the procedures too, by the way. As you do this, you generally have the procedures right next to you, and you're reading through them and just following the directions. This O-ring here, this will go on top of this filter. Let's see. The next slide does not show it. And then you take the whole apparatus and you screw it back together. So your filter is held within this apparatus. Now, the important thing is that you never touch the filter with your hand so you don't contaminate it. The next job is you take one of your amber bottles, actually give it a little bit of rinsing or invert it a couple times. Don't shake it vigorously like crazy, because that can kind of start breaking apart your algae cells. So just do a little light mix. And then what you do is you fill this up the entire way up to the top. You rinse that water out in the sink, and then you fill it up again. And when you fill it up again, you'll be going up to the 60 cc line. You turn this whole thing upside down, and then you plunge it to the 50 cc line. So you get rid of a little bit of the excess because you originally put 60 in. And the reason you do that is so that you know that you have exactly 50 after you do that little bit of plunging. Another step you want to make sure you do is give it some taps. If you see any air bubbles in here while you're doing this process, tap those air bubbles out. Force the air up to the top so that when you do this plunging, those air bubbles will be forced out of the syringe. You then set up your syringe so it looks like this. You attach, this is that little piece that we showed you earlier that is holding the filter. This little piece can attach on the syringe. And then you just give this a slight pressure. So you're forcing the water through the filter paper that is in this, this little filter holder apparatus. Okay, so I don't have a slide of this. This is what we like to try to demonstrate in person. You try to achieve a rapid drop rate. If you shoot the water out like a water gun, like really fast, you will rupture your filter and you'll have to start over. So what you want to do is apply just enough pressure so you get a drop rate that's kind of like this, like a drop, 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 drop. So you kind of do it at a rather slow rate, and it does take a little bit. You know, it might take anywhere from 5 to 10 minutes to do this at that type of drop rate. So the reason we're just being careful is because we don't want, there's a couple things. We don't want water to be leaking out the side of this thing. If you don't have it screwed just perfectly and with the threads all lined up, and if you're pushing too hard, then water can actually start coming out of the side. And if that happens, you want to start over. And we also just don't want to puncture the filter. So a nice slow drop rate. Once you do that, take it off, unscrew it, and then your filter is going to be covered in algae cells. So with your tweezers and a pin, you're going to fold that filter into quarters. First you fold it in half, like shown here, and then you'll fold it again, so you'll have something that looks like a little pie piece. Now when you do the folding, obviously you want to fold it so that algae is trapped inside the folds. We're trying to prevent any of that algae from getting scraped off of the filter. So there's our final product there with the folding. It looks like a little pie piece. It's in quarters. And you take that and you are going to add it or put it into one of these sample vials you have. Also in this step, it looks like we've already added the label to this vial. Make sure when you add the label, you put it as shown here rather than wrapping it around the other way. If you wrap the label around the wrong direction, you actually can obstruct part of the label. You won't be able to see part of it. So if you wrap it around just like this, you'll be able to see the entire label. The next step is to do it all again. You have to filter, you grab your other amber vial and you filter another sample. So you will end up with two vials, each with their own filter paper in them. And then you wrap it up in tin foil, or aluminum foil, I guess. It's not actually tin. It's aluminum. And you want to do a good job. You want to block all of the light. If you turn your sample in and you have forgotten to put aluminum foil on it, then the sample has to get rejected by the lab, and you won't be able to use your sample. So it's a very important step. So do not forget the aluminum foil. Wrap it up really good, no light getting in there. And then you can put it in a baggie, label the baggie with the month and the date or the lake that you did it, as well as with your name. And then put your data sheet in the actually the best way to not lose your data sheet is just to put the data sheet in with the samples in its own baggie, and then they all go in the freezer. So that way everything stays together. Then according to the proper schedule, you turn in both your phosphorus and your chlorophyll into the DQ drop-off point, and then they'll put it in the freezer. And what they do with it is they put it into freezer boxes and overnight ship it to MSU, and MSU processes the samples. So just gist of this is just kind of going over what I just talked about. When you turn in your sample, so for example, it's July 21, and you're turning in your first 3 sets of samples. You got your May, your June, and your July samples. They're all wrapped up in aluminum foil, and they all can go in the same baggie together. And then you put your data sheet in that baggie with them. Just like phosphorus, there is components that you can enter into the data exchange. So this is just a reminder. If you need a login or a password in order to enter your own data into the data exchange, this is the email that you write to get that. This is actually a decent spot to just check with everyone if you have a question about the process and how to filter, how to collect the water, really anything related to chlorophyll.
Okay. We did have a few questions come in that may have been related to the previous sessions because they came in right as you were getting started with the chlorophyll.
Okay. Well, we might just take them all.
Sure. So first, what do you recommend for lakes that have several deep spots or lakes that are chains of lakes?
Yeah, all of those will take a little bit further discussion and looking at the exact situation. So that's something that you would work on with us over email or phone or something. So give me an email about that if you guys have not yet had picked that deepest point.
Okay. Can this program accept data from other labs?
Generally speaking, no. In terms of maintaining the consistency and the data exchange, we are only taking data from our program. However, there's a possibility that could change in the future. That's something that could be up for a bigger conversation. So that'd be something else that you could contact me personally about.
Okay. And the last question that we have right now is, what is the turn-in date for the UP counties?
Bear with me while you might want to close your eyes because I'm going to flip back a whole bunch of slides. Prevent you from going blind. Okay, so for the counties you see listed here, circled in red, that turn-in date is September 1. However, notice that that is not every single UP county. I don't have the whole schedule actually written on this PowerPoint slide. Some of it got cut off. So if this isn't the county that counties you're referring to, then you actually have to just get that schedule for yourself and look it up.
And that's available from the CLMP documents page.
CLMP documents page, that's right.
Any other questions while we're taking a quick moment here? Oh,
only got a handful of slides left.
There's one more question that just came in. Does the volunteer in your slides ever defrost his freezer?
I'm pretty sure that was a DEQ lab somewhere, and who knows what they do. It's probably been about 30 years.
Sure.
That's so funny. Someone always notices how bad that freezer is.
Keeping the humor here. All right, well, that's all the questions we have at this point.
Let me just give a few thoughts about what all this data means and how we interpret it. We give a pretty good explanation of this in our programmatic manual. So if you go to that CLMP documents page, I think the very first link on there is the CLMP manual. So to get more information about what I'm about to talk to you, go there. At the end of the year, you'll get this data report as I showed you the cover of it in our last presentation. Here's an example of what the chlorophyll section will look like on the inside of the report. It will give this year's year, so this is the data that you just took. And then I also summarize the last 5 years and then summarize all the years that the lake has been enrolled in the parameter. So we give the min and the max measurement. We give a median, and the median is actually for chlorophyll. This is what we're graphing in the graph below. A standard deviation, and then this thing called Carlson TSI. TSI stands for Trophic Status Index, and that is a number that gets assigned to chlorophyll, gets assigned to phosphorus, and it gets assigned to Secchi disk. And that's a number that gives you, can be used to determine if your lake is oligotrophic. You may have heard these terms before, mesotrophic, eutrophic. Those are general rankings of whether you have a little bit of nutrients in your lake, like a really clear lake that maybe you can see down 30 feet, not very much phosphorus. Mesotrophic lake is kind of in between, and then a eutrophic lake might be one you only can see down 5 or 6 feet. Lots of algae, lots of phosphorus. So, so these numbers give you a sense of where on that spectrum your lake lies. In the summary here, this lake has an average of 35. So I averaged the Carlson TSI number from the transparency, from the chlorophyll A, and from the summer total phosphorus, and that gave me 35. And then, let me skip a few slides here. And then we have in our program manual, you will see this graphic. And so this shows you the range of what TSI can be. In this case, anything less than a 38 is considered oligotrophic. So that lake we were just looking at with a 35, that would be in the oligotrophic range. And you can really see it's a spectrum. It's really hard for a lake to say, oh, we are definitely mesotrophic, because they could be on the low end of mesotrophic or the high end of mesotrophic. So these are really general categories, but the best thing, that's why these numbers are so helpful, is because they really give you a good sense of where on the overall spectrum your lake falls. So I won't go over every little bit of detail in here, but that's what the Carlson's Trophic Status Index is going after. It's letting you put a number to all these measurements you're doing, and it's a good communications piece, I suppose, because it's putting things pretty simply so that you're able to report on your data and say, you know, in a newsletter article, you write to your lake association, you say, hey, our score this year was a 43. That means we're right in the middle of the mesotrophic category. That means our lake is it's kind of middle of the road. It means that the water's not overly turbid, but there's still some phosphorus in there, you know, that kind of thing. So it's a good outreach tool, I think. Just to give you a sense of how lakes fall across the state, in 2010 I put this graph together just with the lakes that were enrolled that particular year. And honestly, from year to year, this changes very little. Most of the lakes, over 50% in Michigan, are mesotrophic, so they fall in that middle category. Moderate amount of nutrients, probably Secchi depths of 12 to 20 feet, somewhere in that range. And then there's a good portion of oligotrophic lakes as well. Notice that not all oligotrophic lakes are located up north. That's something that always interests people. You think northern Michigan as the clean place and southern Michigan as agriculture, but there's a lot of good lakes in southern Michigan. Good in terms of low nutrients, generally how people think of lakes. And then there's a handful of eutrophic, and every year 1 or 2 hypereutrophic lakes, which are very, very high in nutrients, end up in the program. Okay, so that concludes everything I wanted to talk to you about. We're going to do some questions, but before anyone leaves, I just want to make sure you remember your assignment, which was go to that. Actually, I'll just bring that slide up so you can remember. I want you to watch that video before you get up from your desk or your table.
And I actually included the website address again in the follow-up email you'll be getting from me with the survey.
Yep. It's really important you watch the video because the filtering process is complicated enough that for years and years and years we insisted that everyone had to come live in person to the training. And with trying a webinar for the first time, we're a little nervous about people trying to do the filtering without seeing it in person. And I think the video can cover it, but I think it just highlights the need to watch the video. The still images aren't good enough to really get a sense of what's going on. So, anyone have questions? Now's our chance. Let us know. Let's wait a few minutes as you think about that.
No questions.
No questions. Okay.
No questions or comments? Oh, here we go. All right. We just found out about the CLMP and didn't register our lake yet. If we register it now, will we get all the equipment in time for the turn-in date? I think there are only 2 parameters that are still open.
Yeah, so a lot of the registration is time limited. So we're glad that you found out about us sooner rather than later. I believe you can still register for Secchi, and you still should be able to register for summer phosphorus. All the other enrollment dates have gone by, so you'll have to next year. You know, you'll know to look sooner and be able to get in. If you register before April, just as a rule of thumb, then there's no problem in getting into everything, I think. Actually, I think I should say register before beginning of March, and then you won't have any problems. Because I think spring phosphorus has a registration date of like March 15 or something. So anyway, so the registration page is, if you go to the MiCorps.net, go to lake monitoring, and then this become a volunteer or program enrollment. Let's see what become a volunteer does. This just gives some information along with all those deadlines. How much it costs. And then, yeah, and then a link to the enrollment page.
Similar question, I believe. This one says, I am new and missed the start. How do I begin? Well, I will say that we are planning to, assuming this recording went well this evening, we are planning to have the entire webinar archived up on the program website. So I will be sending an email out if and when that is available to you all. So if you missed the start of the webinar, we can help you in that way.
Yep. Another thing you could do, really, this website is where to begin after the webinar. Watch the webinar, and read anything on this under lake monitoring to specifically learn about the CLMP. Under CLMP documents, there are videos for Secchi, there's a video for phosphorus, and there's this video for chlorophyll. So watch all of those. Yeah, so I think that's how you start. Any other questions? We'll give people a few seconds to get all the typing in, or you can ask over the phone if you want.
What about E. coli monitoring?
Someone always asks about E. coli. Yeah, that is a parameter that was discussed to add to the program, and we've decided that that might be one, because of its great variability, that we would leave that to the professional health departments. So this program will not get involved in E. coli monitoring.
Okay. Any other last questions before we sign off?
Sorry. Thanks everyone so much.
Thank you all. We really appreciate your participation tonight, and we look forward to hearing your feedback. So when you get the email from me shortly, please take a few minutes to fill in the survey and send us your thoughts. All right.
Thanks.
Thanks everyone. Have a good rest of your evening.
Don't forget your homework.
Yeah.
Take care.
All right. Good night.